Toddlers, I hope you guys are having an awesome long weekend. Georgie here with me. We are still at Suncadia and we've had the best time. Oh, are you going to show them your tongue? Just got the tongue. We're getting into lesson 13 here, you guys. And we're going to be using benchmark numbers, which are just whole numbers or mixed numbers with a half, to consider the reasonableness of our final answers. Georgie, put away that tongue. So really what we're doing, you guys, is just pausing and making sure that our final answers land where they should on the number line. So we're going to continue work with subtracting fractions, finding common denominators, all those things that you guys have been doing such a terrific job with. So let's get some practice in. Say bye-bye, George. Here we go. Dudettes. We are here, as you know, in Lucky Lesson 13. And do we have kind of an odd learning target? Yes. But is it going to help us check in with our logic? Yes. Is logic important when it comes to math? Yes. Okay, so we're just going to kind of roll with this. Let's find a more interesting color than black. How about like a dark, I was looking for like a dark green. Yeah, that works. Coming from Suncadia, we are home now, back in Kirkland. I'm thinking of all these gorgeous evergreen trees covered in snow. For those of you that have not been to Suncadia, I'm sure probably everyone listening to this has, at least my kiddos that are my class. What a gorgeous place. We had the best time. Gosh, it was awesome. We went ice skating for the first time. Cal was so good at ice skating, obviously. We had s'mores, we went sledding, had hot cocoa. It's just the best. Okay, anyway. So I cropped out the darn instructions, but here for this section, we are supposed to fill in the blank line with these three symbols. And yes, we can calculate, but let's just do our best using mental math and the benchmark numbers. Benchmark numbers are just halves, wholes, and then, of course, the halves in between. So half, 1 and 1/2, 2 and 1/2. These are benchmark numbers. These are like kind of touchstone numbers that are, we can typically easily round. We can round this to a benchmark number. Let me try to fill in some more of this so we can see exactly what these benchmark numbers entail. Do you guys kind of see what's going on here with the benchmark numbers? They're just like nice round numbers. 5 and 1/2. Okay. Okay, so 5 2/3. Let's think. We're going to be doing some rounding. Let's think. 5 2/3. Is it closer to 5? 5 1/2, or 6? I'm going to go ahead and say 6 because 2/3 is technically, and this is so strange to even introduce, 1.5 over 3 is equal to 1/2. We don't want to have decimals and fractions, that's just wrong, but let's think about 5 2/3 being pretty close to 6. 3 3/4 is pretty close to 4. 6 plus 4 is 10, so is 10 greater than, less than, or equal to 8 2/3? Greater than. Do you guys see how we're using these benchmark numbers to think about what our answers will be in comparison to, well, I guess we can consider this a benchmark number, but here in this first one we don't even have to. Okay, let's continue this conversation over here. 4 5/8. I'm going to go ahead and say 4 5/8 is pretty close to 4 4/8, which is actually 4 4/8. An equivalent fraction to 4/8 is 1/2. So 4 5/8 benchmark number is going to be 4 1/2 that we can connect that to. 3 2/5. This is tricky. I'm gonna go ahead and round 3 2/5 down to 3 because it's just 2/5 away from 3. So 4 1/2 minus 3 is going to be, I wish I had some more room to work here, is going to be 1 and 1/2. So 4 and 1/2 minus 3 is going to be 1 and 1/2. Let's see what we have over here in terms of benchmark numbers. 1 and 5/8. 1 and 5/8 is just, 5/8 is just 1/8 away from 4/8. So let's rename 1 and 5/8 as 1 and 4/8, which is actually equal to 1 and 1/2. 2/5. 2/5. Let's think about what 2/5 looks like. I'm going to try to break this into fifths, 5 equal parts. 2/5 is that many slices. 2/5 is pretty close to 1/2. So let's go ahead, and this obviously, you guys, this is just very subjective. This is just what makes sense to your brain using reason and logic still. So let's go ahead and look at 1 and 5/8 as 1 and 1/2, and 2/5 as 1/2. 1 and 1/2 plus 1/2 is equal to 2. So if we're comparing 1 and 1/2 and 2, the sign that we're going to use here on the blank is going to be less than. 1 and 1/2 is less than 2. This side should be less than this side. Okay, let's go ahead and look at this next one here. I'm actually going to look at this side first. 6 plus 13/4. 13/4, my friends, is really close to 1. It's almost 14/4. 6 plus 1, and we don't have to do anything to 6. You know what, I think I'm going to get rid of these benchmark numbers. I hope you guys had a chance to look at those, but Mama's running out of room. 6 plus 1 is 7. Okay, let's see what we have over here on the left side. We have 5 and 1/2 plus 1 and 3/7. 5 and 1/2 we don't have to do anything to. That's already a benchmark number. Let's think about what we can round 1 and 3/7 to. 1 and 3/7, again, that's pretty close to 1 and 1/2. 3/7 is not exactly 1/2, but it's pretty close. We'll go ahead and round that to 1 and 1/2. So let's think about what is 5 plus 1 is 6. What is 1/2 plus 1/2? It's 1. So what we're looking at here is 6 plus 1, which is 7, versus 7. So these, you guys, should be about equal. Left side versus right side. Let's look at one more here. Here we have 15 and 4/7 minus 11 and 2/5 versus 5 and 4/7 plus 2/5. Okay, so benchmark numbers, 4/7, I'm going to go ahead and rename that as 15 and 1/2. Because is 4/7 equal to 1/2? No, but they're pretty darn close. Same with 2/5. 2/5 is not equal to 1/2, but it's pretty darn close. So I'm going to rewrite this left side here, you guys, as 15 and 1/2 minus 11 and 1/2. What is 15 minus 11? Well, it's 4. And then 1/2 minus 1/2, of course, is nothing. So here we have a 4 on the left side. Let's see what we're looking at on the right side. 4 and 4/7. 4/7 is very close to 1/2. So let's rename this as 4 and 1/2. And then 2/5, really it's just 2 away from 0/5. So let's go ahead, I know it seems kind of funny, but let's just go ahead and rename that as 0. Because again, it's just, no, I don't like that. It's actually closer to 1/2. And here's the thing, you guys, either way you go, as long as you can back it up with your reasoning, you're fine. 2/5 is not equal to 1/2, but 2.5/5 is equal to 1/2. So we're actually just 5/10 away to 1/2 here, or a fraction that's equivalent to 1/2. So let's go ahead and round that 2/5 to the nearest benchmark number, which is 1/2, or at least the benchmark number that's equivalent to 2/5. Like I said, it would actually be 2.5/5 is equivalent to 1/2. And again, I'm not expecting you guys to get into fractions and decimals combined, but I just want you guys to see that this is actually exactly 1/2. 2.5 over 5. Okay, so let's evaluate what we have going on over here. So we're looking at 4.5 plus 1/2, which is equal to 5. So the symbol that we need over here is less than, because 4 is less than 5. You guys kind of see what's going on here? Let's look at a few more examples that'll be very... Okay, buds, we're going to take a look at just a few more examples here, still keeping in mind those benchmark numbers. We'll change our colors here. Benchmark numbers, again, for this lesson are halves that occur right in the middle of whole numbers. We have half, 1, 1 and 1/2, 2, 2 and 1/2, 3, 3 and 1/2, ... which means this pattern continues. And they're benchmark numbers because we're really comfortable with whole numbers, and then we should have a really good handle on exactly what a mixed number, including 1/2, looks like and kind of feels like. So let's look at these here, where we're asked are the following expressions greater than or less than 1/2 benchmark number? Circle the correct answer. So 1/5 plus 1/4. 1/5, that's a tiny, tiny slice, plus 1/4, another tiny, tiny slice. Do you think that's going to be greater than 1/2 or less than 1/2? Well, just to be completely sure, let's just go ahead and evaluate this expression really, really quickly. You guys know that we have to find a common denominator if we're going to add 1/5 and 1/4. I'm going to find a common denominator of 20 between 5 and 4 by just multiplying them together. So I multiplied 5 by 4 to get 20. Now I need to multiply 1 by 4, which is 4. Multiplied 4 by 5 to get 20. Now we have to multiply 1 by 5, which is 5. So we're looking at here, you guys, is 4 20ths plus 5 20ths, which is 9 20ths. Is that greater than 1/2 or less than 1/2? Well, 9 20ths is less than 1/2. 10 20ths would be the equivalent to 1/2. This is less than 10 20ths. So for this first one, we're looking at less than 1/2. Let's look at this one here, you guys. We have 6/7 minus 1/6. We are so, so great at finding common denominators, so let's just evaluate this one really quickly by multiplying the denominators together. 7 times 6 is 42, so we'll use that as our common denominator. I multiplied 7 by 6 to get 42, which means I need now to multiply 6 by 6, which is 36. Make sure we realize that we're doing subtraction here. And then let's look at our equivalent fraction to 1/6. Well, I did 6 times 7 to get 42. Now I need to do 1 times 7, which is 7. So 36 minus 7 is what we need to calculate. 6 minus 7, can't do it. I need to do some unbundling. I can do 16 minus 7, which is 9. 2 minus nothing is 2. So what we're looking at here, you guys, is 29 42nds. Is that greater than or less than 1/2? Well, what is equivalent to 42? Or I'm sorry, what is the 1/2? What is equivalent to 1/2 if we have a denominator of 42? Well, that's pretty tricky. 1/2 is lowest form. 29 42nds is also lowest form, but it might be tricky to consider, is that less than 1/2 or is that greater than 1/2? This is what we need to ask ourselves. Is 29, if we double 29, will we get 42? If we double 29, will we get 42? Let's think about it. 29 times 2 is 58. So what I'm thinking, you guys, is this is greater than 1/2. 29 over 42 is greater than 1/2. If we wanted to look at a fraction that's equivalent to 1/2 that has the denominator of 42, what we would have to do is consider, what is 42 divided by 2? I think some of us can actually do this in our head. We can also do really quick long division. Just right here. You guys are experts at this by now. 21 over 42 is equivalent to 1/2. So anything above 21 is going to be greater than 1/2. So indeed we were correct here. Nice job on that one, you guys. Do you see how in this lesson we're just kind of checking in with our logic? We're just kind of exploring relationships between numbers. We're and basing this exploration on everything that we've been working so far in Module 3. Let's look at this next one. We have 1 1/7 minus 5/6. I don't want to go ahead and evaluate this. Let's use our benchmark numbers and consider what's going on here. 5/6, you guys, is really close to 1 whole. 1 1/7 is really close to 1. If we subtract those, we're going to have 0. Is 0 greater than 1/2 or less than 1/2? Well, it's actually less than 1/2. That's our calculation based on our benchmark numbers. Let's go ahead and evaluate this and see if our actual difference is indeed less than 1/2. In order to do that, I need some more workspace here. This is my erasing music. And you guys might notice that I'm using a whispering voice. I'm hiding in Mr. Calamaris' office while I do this video because I have 2 little boys that are looking for me. It's kind of mean that they're searching the house. Mama, Mama, I don't know if you hear them calling out to me as they're walking through the hallways wondering where I am. I'm right here, guys. I just have to do my math video. Okay, so let's look at a common denominator between 7 and 6, you guys. Common denominator between 7 and 6 can be 42 because I just multiplied those 7 and 6 together. So let's not leave 1 behind. We multiplied 7 by 6 to get 42, so now let's multiply 1 by 6, which is 6. Here for 5/6, we multiply 6 times 7 to get 42, so now let's multiply 5 by 7, which is 35. Oh dear, we're in that funny situation again. We cannot take 35 from 6, so we're going to have to cash in this 1 whole for 42 40-seconds plus, don't forget that, 6 40-seconds. So what we're dealing with in this huge blob, you guys, is 42 40-seconds plus 6 40-seconds, which is equal to, just add 42 plus 6, 48 40-seconds. Okay, so now the expression that we're looking at, my friends, is 48 40-seconds minus 35 40-seconds. 48 minus 35 is going to be 3. Is going to be 13 40-seconds, which is less than 1/2. Woo hoo hoo. So excited for you guys. I hope you guys, I won't say I hope. I'm confident that you guys get the idea as far as what we're working on in lesson 13. We are evaluating expressions. We're rounding some expressions to the nearest benchmark number, just so that we can really have a very solid foundation of proper logical answers once we get to the final answer. So our secret word from Tuesday morning is going to be, where did Mrs. C go for that beautiful, snowy, fun-filled weekend over this long holiday weekend? Where did Mrs. C go? Hope you guys enjoy the rest of your afternoon. Cannot wait to see you guys bright and early tomorrow morning for another wonderful week in 5th grade. I will see you guys in the morning. Bye for now.